In question 16, we have a smooth sphere P of mass 3m. P has a mass of 3m and velocity 4u. Impinges directly on another sphere Q of mass 5m and velocity 2u. We set up our little table. We want to do a before and after. We've got our before, we've got our mass, and we've our after. So what's happening here? They're moving in the same direction. So we've got positive u's, and the coefficient of restitution is e. For what value of e will the velocity of p be halved by the impact? Well, if the velocity is to be halved by impact for p, it's going to go to 2u. So we'll always call these p and q. So let's just call this one q, and we have a value for p. So using our equations, m1u1 plus m2u2 equals m1v1 plus m2v2, and v1 minus v2 over u1 minus u2 being minus e. We can find two equations if we need to solve what we need to solve. So using the first equation, conservation of momentum, we're going to get 3m times 4u plus 5m times 2u is equal to 3m times 2u for it to be halved plus 5m times q. Dividing by m. So we divide it by m, we're going to get 12u plus 10u equals 6u plus 5q. So 22u minus 6u, 16u is equal to 5q. So q is equal to 16u over 5. If you can hear the dogs fighting in the background, that's because they are. Using our second equation, v1 minus v2 will be 2u minus q over 4u minus 2u. You could just write 2u if you want, equals minus e. We're going to get 2u minus q is equal to minus 2eu. So q going to the right will be positive. Bring in 2eu to the left. We'll make that positive. So q is equal to u times, so we factor out u, 2 plus 2e. So now we have two values for q and we're asked the value for e. So we should be able to equate these two. 16u over 5 equals u times 2 plus 2e, and you can see here we can divide by u and we'll just be left with e. That's the only unknown. So 16 is equal to 10 plus 10e, cross multiplying. We're going to get 6 is equal to 10e, so e is equal to 6 over 10 in this question, or 0.6 for part 1. Part 2, show that whatever the value of e, in e being between 0 and 1, the velocity of q after impact will be at least 2.75 u. So we need to focus on q here this time. So regardless of the value of e. So we're going to use the p and the q now for speeds afterwards. So our equations are going to become 4u by 3m plus 2u by 5m is equal to 3m times p this time and 5m times q. Dividing by m, we're going to get 12u plus 10u again is equal to 3p plus 5q. So 22u is equal to 3p plus 5q. So we have three unknowns in this equation. So let's see what happens with our next one. v1 minus v2 is going to be p minus q over u1 minus u2. 4u minus 2u is going to be equal to minus e. So p minus q is going to be equal to minus 2eu. So just Back to the question for a sec. We're focusing on Q here. So the velocity after Q. So let's just focus on Q. So if we can get rid of P, maybe that might help us. So if I multiply this one by a -3, I'll get rid of P. Start that minus 3P. Apologies if you can hear the drilling. The dogs have stopped fighting and the drilling has started. Minus 3P plus 3Q is equal to 6EU. Let's see, does this help us if we get rid of P? 3P plus 5Q is equal to 22U. So if we add these two lines together, we're going to get 8Q is equal to 22U plus 6EU. Now we're asked something about E here, so let's simplify this down. Well, we can divide by 2. 4Q is equal to 11U plus 3EU. If we factor out the U, 4Q is equal to U times 11 plus 3E. So Q will be equal to, this is the speed after impact, U over 4 times 11 plus 3E. So we can look at the max value of E is 1. So what's the max value here? The max is when E is equal to 1. So Q is going to be equal to U over 4 times 11 plus 3, 14. And that's equal to 14 over 4, 7 over 2. 3.5U, and then the minimum E is equal to 0. We're going to get Q is equal to U over 4 just times 11 this time, which is equal to 2 3/4, 2.75U. And the question asks us to show whatever the value of E, the velocity of Q after impact will be at least 2.75, and we've shown that it's going to be between 2.75 and 3.5. So, question finished.